Dr. Stern, could you first tell us more about yourself, like your background?
Sure. I'm a planetary scientist and aerospace executive. I grew up in Dallas, Texas. I went to the University of Texas in Austin and I studied physics and astronomy for 2 undergraduate degrees. I did a master's degree there in aerospace engineering. And then I went to work as an engineer. Later, I decided to become a scientist and went back to graduate school and took a PhD in astrophysics and planetary science. Um, and then I've worked on space missions ever since. I've been involved in 30 of them now. I've been in charge on 15, and I've flown to space on one of them.
Wow. Wow. So, the New Horizons mission is like what a lot of people like to attribute to you. So, what is like the significance of it, and can you explain what it is?
Sure. Well, New Horizons is a NASA space mission, a robotic space mission, no people involved.
Yep.
It was launched in 2006 to explore the planet Pluto and its system of moons, and then the region beyond Pluto called the Kuiper Belt. This was the first exploration of either Pluto or the Kuiper Belt by any spacecraft. So it was really history making. Pretty expensive project, almost $1 billion, counting the launch and the flight and everything else. About 2,500 men and women were involved, and I'm in charge of it all, have been since we started.
Okay, so yeah, but back then in 2006, at that time, getting to Pluto was seen as like a long shot, especially with how far it was. So, what made you specifically bel and your team believe that it was not only possible, but like worth pursuing?
Well, those are two different questions, but they're both good ones.
Yeah.
Um, at that time, quite a number of spacecraft had flown very large distances into the outer solar system, like the Voyagers. In fact, at the time that we launched New Horizons, the Voyagers were almost 30 years in flight
Mm.
with much older, more primitive technology. By 2006, the Hubble Space Telescope had been flying for 16 years, and I could name lots more missions. So our journey, which was 9.5 years to cross the entirety of our solar system, while demanding, was not groundbreaking. What was groundbreaking was doing the mission so quickly in terms of its development and at a much lower cost than the Voyagers. And also the fact that we could only send one, so there was no backup.
Yeah.
What made Pluto so compelling scientifically was the fact that in the 1990s and early 2000s, as the Kuiper Belt was first discovered by ground-based telescopes and then surveyed, uh, it was discovered that there are many small planets out there about the size of Pluto, but a little smaller. And so, beyond the fact that we knew that Pluto was interesting for having 5 moons and an atmosphere and active surface geology and other attributes, it also turned out that Pluto wasn't kind of an oddball beyond Uranus and Neptune, but the first of many to be discovered. And so by going to Pluto, we hope to learn by example what many of the others in that class are like. And that's what we did.
Yeah. Okay, that's awesome. But it's 9 years to get out there to actually get to those planets and to Pluto. So, what were like some of the biggest scientific or technical uncertainties that came with that cruise phase to get out there?
Well, there were a couple that come to mind. One is the fact that, when the Voyagers flew out in that part of the solar system, they didn't go to Pluto, but they flew to Neptune and beyond. And they had a team of 450 people to run those two spacecraft. And, in 1970s and 80s technology, it took a lot of people. By the 2000s, we had much better technology. And so our team was less than 50 people, about a tenth as many people. And part of the challenge was to just make sure that we got all the work done with 10 times fewer people and that we didn't take any undue risks with the spacecraft.
Okay, well, I'm just curious.
Hmm.
So when those first images of Pluto came in and you saw them, like what kind of went through your mind when you first saw them?
Wow.
Yeah.
Wow. This is better than I thought. Look at that, giant range of geological expression. Look at those mountains and ice volcanoes and glaciers and all the complexity in the atmosphere. And look at all five moons and how different they are from one another.
Yeah.
Uh, Look at
Uh,
how the surface is different colors and different compositions in different places. This little planet has got a lot to teach us.
yeah. Was there anything that was like super surprising that kind of rewrote the expectations that we had?
Sure. Um, Usually, what we found in planetary science as we explored all across the solar system is that as you travel to smaller and smaller worlds, they tend to be simpler and simpler, and they tend to run out of energy because of just the fact that they're small. It's the same idea as like take a vat of coffee and a cup of coffee. Which one's going to cool off faster? The little cup, because the vat and the cup have different ratios of their surface area to their mass. And so the vat holds the heat better. Same way big planets hold heat better, little planets cool off more quickly, like the Earth's moon, which geologically died about 1 billion years after its formation, 3 billion years ago. But Pluto, even though it's smaller than the Earth's moon by a little bit, it still turns out to be very highly active, which really surprised us because we'd never seen anything like that before. So it taught us that there's some physics and some chemistry that we hadn't seen before and that might be common in the universe that Pluto was showing us by example.
Okay. So after, okay, so moving along after Pluto, the extended mission took New Horizons to Arrokoth is what it's called. How did that flyby like deepen our understanding of the early solar system?
Yeah, well, that's a great question because Arrokoth is a much smaller body than Pluto. It's only about the size of like the island of Manhattan, whereas Pluto's like the size of the United States.
Wow.
Arrokoth is very, very far out, even much farther than Pluto, and the temperatures on its surface are getting towards absolute zero. Out in that outer part of the solar system with temperatures that cold, the objects like Arrokoth are very well preserved from the formation days of our solar system. So, Arrokoth, in studying its geology and its chemistry, what it's made of, how it's shaped, and so forth, we could learn a lot about how the seeds of planets, things the size of Arrokoth, built up much bigger objects like Pluto.
Okay. So in terms of planetary formation and geology, what do both Pluto and Arrokoth together teach us like that we couldn't learn from our inner solar system missions?
Well, first, we had never seen examples of solid bodies like that were formed in orbit around the sun that far out. Gotta realize, Pluto on average is 40 times farther than the Earth from the sun. It's vastly farther. Imagine if you made a scale model of the solar system where the sun was at your home on your street. The Earth would only, let's say the scale is the distance from the Earth to the sun is one house, your next door neighbor's house. So Mars would be two houses down the street, and Jupiter would be four houses down the street. But Pluto, 40 houses down the street. It's way far away.
Yeah.
And it samples a whole different part of the solar system where things formed potentially very differently and certainly under much different conditions.
Okay, so let's say for instance you were like given the green light to lead another mission to Pluto to the Kuiper Belt. So what would it look like? And like what would you try to aim and answer this time for this new mission?
That's another good question. So
Yeah.
what I would do is something that we studied um, a few years ago, and it's called the gold standard mission. And it involves nuclear electric propulsion to put a spacecraft not just at Pluto to fly by it, but to go into orbit and stay there for some years to study it in much more detail and with much more sophisticated gear on board, more sophisticated instruments. And then it has the power to get out of orbit and to go on and explore the diversity of things in the Kuiper Belt. Because we only studied Pluto, one of many dwarf planets, and Arrokoth, one of literally billions of small Kuiper Belt objects. With the gold standard mission, we can study Pluto in more detail and then go on to half a dozen more Kuiper Belt objects and a couple more dwarf planets. So that would really give us a comparative context of both types of objects. And that's the next important step.
Okay. So you've also been like a passionate advocate for Pluto actually being an official planet and getting its planethood. So why do you believe that the classification of it still matters?
Well, all of science is a reductionist enterprise. In other words, we take masses of facts and try to distill them down to find patterns. And when we look at objects like Pluto, they very obviously look like planets. They have the geology and other characteristics of planets. And so we want to properly categorize them. Um, a good example might be uh, if you saw a baby calf and a full-grown mother and father in a field in Texas, um, it would be wrong to categorize the baby as something other than a calf, you know, simply because it's smaller. It has the same shape as its parents, the same composition, the same genetics. And in the same way, while Pluto is a smaller planet than the Earth, it doesn't make it not a planet. And so most planetary scientists, most professionals in my field, um, feel that not just feel, but know from the science that these smaller planets belong categorized as planets, just like smaller stars are not categorized as something else besides stars, but as small stars like the sun.
Okay, so now I want to move on to like outreach. So students and aspiring explorers that are listening to this conversation, do you have like a message about why pushing toward the edge of the solar system still matters?
It matters because it's humanity's future. We are destined uh, to not only explore our solar system, but to make it our own, part of our economic sphere, the same way that we went from being a species that was only in Africa to inhabit all corners of the earth and make a much better society as a result, with much more advanced technology that can take care of people better. And the expansions of space will do the same thing.
Yeah, so do you have any advice for like people like me, my age, or other students to when if they want to become like an engineer, if an engineer get into aerospace, what could they do?
Well, most important is that you find what you really love, whatever field of engineering or science. And for that matter, in space exploration, we need writers, we need journalists, we need computer scientists, we need every profession you can think of, even people that are business majors, because a lot of space is now commercial space. So find what you love, study it, and really excel at it so you can go to the top and get the best jobs, and then come be a part of opening the universe as an explorer in
Yeah.
whatever profession you have.